So this is the fourth CATS Maths, and today we're going to be working on word problems, setting them up and understanding what they mean. So our first problem is a 16-inch candle and an 8-inch candle are lit at 7 p.m. The 16-inch candle burns at 1.5 inches an hour, and the 8-inch candle burns at 1/4 inch an hour. At what time will the two candles be the same height? So the important information from this problem is that we have two candles, right? Candle A and candle B. And candle A starts at 16 inches. Candle B starts at 8 inches. And then they are losing height. So we know that A is losing height at 1.5 inches an hour. And B is losing height at 0.25 inches an hour. So, what's the main idea from this problem? We're looking to find what time the two candles will be the same height. So we want to know when candle A equals candle B. So I have almost two equations for that, right? I have A, and it's 16 inches, but then it's losing height. And then B, which is 8 inches, and losing height. So if A equals B, well, I can write it like this. And then solve. So just, some algebra. You've got 8 equals 1.25t. Divide by 1.25. Divide by 1.25. And you get t is equal to something like 6.4. So it's 7 p.m. We light the candles. 6.4 hours go by before they are the same height. So what is 7 p.m., right? 7 o'clock p.m. plus 6.4 hours. Well, that's not something that you could do without first figuring out what that looks like in this sort of format. So 6, right? So 7 p.m. plus 6 hours. And then 0.4 is 4/10 of 60 minutes. So 24 minutes. So we're going to add 6 hours and 24 minutes to this time. And because we switch over once we hit 12 hours, we end up saying it is 1:24 a.m. Oops, that's not supposed to be a p.m. That's just hours. So they are the same height at 1:24 a.m. Next, we have a bucket of water. It's got 300 liters in it, and it's being filled at a rate of 15 liters per minute. Then we have a separate bucket that has 450 liters of water, and it's being drained at a rate of 15 liters per minute. And it wants to know how many minutes it will take for the two containers to have the same amount of water. So again, we have some important information. We have bucket A that's got 300 liters of water, and it's being drained, so minus, at a rate, it's being filled at a rate of 15 liters per unit time. And then we have bucket B with 450 liters of water, and it's being drained, so now the minus, at 15 liters per unit time. So the main idea from this problem is how many minutes it will take for the two containers to have the same amount of water. So if A is the amount of water in bucket A and B is the amount of water in bucket B, then we're looking for when A equals B, or when will the buckets be equal. So I have an equation for A almost, 300 liters, and it's gaining 15 liters per unit time, so per minute in this case. And then B, and it's got 450 liters, and it's losing 15 liters per minute. So then we're going to solve, and we solve by setting these guys equal to each other. So we might end up with 150 is equal to 30t. That's what. So t is equal to 5. So it takes 5 minutes for this bucket to lose enough water to be equal to the bucket that gained enough water. And if you want to write that in a sentence, because some of these problems do ask that you write in a complete sentence, you could say, after 5 minutes, the buckets, or actually not after, because they're gaining and losing, right? So at 5 minutes, the buckets will have the same amount of water.